All right, the last type of problem, again, very similar problem statement, very subtly changed. Same feed, same solvent composition. This time, we want to find how much solvent do we need to feed in order to meet a set of specifications with a certain number of stages. So we've got N and the composition of the raffinate specified, and the solvent flow rate is now our main variable, which means this is an evaluate type problem. In other words, evaluate a given system, a given two-stage process to see if it will work for the given specification that you want. So you have freedom to solve for S in this problem. So I'm going to label my solvent and my feed once again and connect them with a mixing line. Except this time, I can't find where the mixing point is because I don't know what the relative amounts of F and S are. So let me go ahead and draw my PFD briefly as well. And now this time, instead of knowing what the solvent flow rate is, I know that I've got 10% in the last raffinate stream. My feed is still the same, 100 kilograms per hour, 30% acetic acid, 70% water. And S, I don't know what the flow rate is, but I know it's 100% vinyl acetate. So I don't know where the mixing point is. So that's one issue, but I'm going to keep going. I know that my last acetic acid is 10%, and I know that it's coming off of stage 2. Therefore, R2's composition is there. And then normally what I'd do is I'd say R2 through the mixing point to the other side is where E1 is, but I don't know where that mixing point is again. So I'm going to start a line, and it could be anywhere. So this is where I have to guess and check again. Instead of guessing what the solvent flow rate is, I'm going to leave that until after I do the graph. So in other words, I don't need to know necessarily what solvent flow rate I have. I'm just going to try graphically to see what I can do. So again, I want to make a good guess here. And I have 2 stages with a less strict system. This means I probably need less solvent flow rate, meaning my mixing point is going to be further towards F than it was before. So before, my mixing point was 67% vinyl acetate. I'm going to say it's a little bit greater, maybe like so. All right, notice that I haven't calculated or guessed what S actually is yet. I'm going to go through and see if graphically it works out before I do any calculation. So I've connected R2 to M, and by default, where they cross must be the mixing point, meaning that E1 is there, and then that will allow me to draw my F to E1 line. And, oh, I might not have enough space to do this. Yep, I'm going to run out of space. So here, I don't know where the delta point is because it's off of my sheet of paper. So that it's not a big problem. It just means that I either need to attach another sheet of paper or shrink my graph a little bit. I am going to, what do I want to do here? I think I did a very poor job in guessing. So I'm going to start over. And I know I did a poor job in guessing because I can see that my E1 tie line is going to be something like that, meaning that my R1 is going to be too close to F. So I'm going to pause, erase, and try again. All right, so let's try another one. Let's try something a little bit closer. Let's try maybe something like so. All right, and I kept my old one on there just so I could know for sure that I wasn't going to do the same thing again. So I've only made a very subtle change, but you should see that there's a little bit bigger of a difference. Maybe there won't be, I don't know. Let's see. See, connecting, oh, just looks like this one is just still off the page. I'm gonna go with that though. I'm gonna see. You can kind of tell where it's supposed to be. It's just off the page here. All right, so I'm going to connect E1 to R1 with a tie line. And now that I have R1, I'm going to connect R1 to delta. Again, looking at kind of where it should be. and where it crosses is E2. E2, and then my second tie line should match where R2 is. And unfortunately, I see now that my guess is not good enough. I need to keep going with guesses. So that's okay. I'm going to pause again and try again. And this time, let's try something a little flatter. I'm going to draw it to where E2 was last time. And I need to make sure that I erase my last line so I don't get confused. And also erase my old extract points. All right, so connect F to E1, like so. Connect E1 to R1 with a tie line. Connect R1 to delta. Connect E2 to R2. Now I've got, in 2 stages, I've got good agreement. So my second stage landed at R2. So I would call this the correct solvent flow rate. Now what I can go and do is kind of go back and see, well, what did I guess in the first place? And I've got lines all over the place. I need to, let's see, clarify again. Let's see, S to F goes like so. Looks like my mixing point is there. Right? Yes, because this is E1 and this is E2, meaning my mixing point is there. About, let's say, 64% vinyl acetate. XVA, the mixing point, is 64%. All right, so let's figure out what solvent flow rate that corresponds to. I'm going to do the overall balance and say 100 times 0 plus S times 1, because the solvent is 100% vinyl acetate, is equal to 100 plus S times 0.64. And this is one equation, one unknown that I can solve for S. Gives me about S is equal to 278 kilograms per hour. All right, so thinking about, does that make sense? Remember, in all the other problems, I had 200 kilograms per hour. I had to feed a little bit more because my stages went from 4 to 2. So it makes sense that I had to feed a little bit more. But then also my target composition went up from 5 to 10%. So that means I have to add less then, because my separation is getting a little bit less strict. So I've got one change that makes me add more solvent, one change that makes me add less solvent. And it happens to be that going from 4 stages to 2 is a little bit greater of a change. And that is why my final answer is 278 kilograms per hour. So again, the one main takeaway that I want you to take away from these lectures is that I show you how to draw the lines, but I really urge you to spend some time thinking about why you're drawing the lines that you are and what drawing a line and connecting it is supposed to mean in terms of doing a material balance. Unfortunately, we don't have enough time left in the semester to keep belaboring this point, so this is where I'll stop with liquid-liquid extraction. We're completely finished. For the rest of this week and on Monday and next week, we're going to talk about azeotropes, and that'll be the last topic that we cover in separations. So that's all for today. Have a good day.